Welcome to Flawless Learning. Data science is not just about collecting data, it's about understanding it. Today, we will explore how to summarize data using descriptive statistics, a powerful tool for revealing hidden patterns in number. Why do you need descriptive statistic? Now, descriptive statistics help us summarize and organize data, making it easier to interpret and analyze. What's the purpose of it? So imagine a library with thousands of books but no catalog, right? Now without descriptive statistic data would be just as messy. Okay. So purpose makes raw data understandable, helps in deleting patterns and outlier, guides decision making in data driven fields. For example, if we have exam scores of 500 students, how do you quickly summarize them? Like, so basically, suppose there's a question that what is the exam score, average exam score of student? Okay, so what is the highest score of student? हम लोग ये पूछते हैं ना कि हाई स्कोर कितना है क्लास में. Okay, so और average score कितना है? That kind of question. Okay, so how can we summarize them? So descriptive statistic provides the answer, right? Now, two key aspects of descriptive statistic. Now, descriptive statistics are divided into two categories. First is central tendency. Okay, so it measures the center of the data, which is mean, median, mode, this kind of thing. Okay, so now second is dispersion, which measures spread of the data. For a measurement of dispersion is range, variance, standard deviation, interquartile range, this kind of thing. So to truly understand data, we need to know where most values lie, which is central tendency, and how spread out they are, like dispersion. So let's start with the central tendency. So first is mean, the average value. So what is the definition of mean or average? Is the sum of all values divided by the number of values, right? Now what is the formula? Basically it's summation over x divided by n. Here this is the equation, this is the symbol of summation. Okay, this is the symbol of summation. So basically summation of x, that means we just sum of all values in the data set divided by capital N, where capital N is the total number of value. Okay, now, what is the characteristic of means? So basically it affected by outlier. So if there is an outlier in a data set, so it affected by the outlier. Okay. So for example, let's break it down that affected by outlier. Suppose there are a data set that 10, 20, 30, this kind of. So what is the average that data set of 10, 20, 30? It's just to sum it 10 plus 20 plus 30, which is 60, divided by 3, which is 20, right? But basically if there is a data set that like 10, 20, 30, and therefore 100. So if we add up them, that is 10 plus 20 plus 30 plus 100, it is 160, and now divided by 4. So basically see, it is like towards the 100, right? So that's why it affected by the outlier. Now works well for normally distributed data. And so what is normally distributed? I will discuss that normally distribution, like normal distribution in the probability and distribution section. Now used in business, finance and research. Okay. Now example, so like exam scores. So what is the mean? So basically sum the all the data in the exam score and divided by total number, like 1, 2, 3, 4, 5. So divided by 5, which is 85, right? So the mean is like the heart of the dataset. It gives a quick summary, but beware of outliers, right? So that's the drawback of mean, that it affected by outlier. Now next is median, the middle value. So median is the median value where data is arranged in ascending order. That's the most important point. That data, you first have to arrange the data in ascending order, then you have to select the middle value, which is the median. Okay. Now, what is the characteristic? It's not affected by the outliers, and it's best for skewed data. And what is skewed data? That I will show in the probability distribution. Okay, because that term, that normally distributed, that skewed distribution, okay, this kind of thing is all the term which lie in the probability distribution. Okay, so till then you can search it, okay, and make it out that what is skewed data. Basically not. Okay, so let me talk about one two line of skewed data. So this basically this is if the data is lie, like there's a data and there's the structured of distribution this. So this is basically normal distribution, okay, and that normally distributed. And if the data is like this kind of asymmetry like this, so this skewed data, okay, and it can also like this also this. So this is the skewed data, okay, basically right tilt and left tilt. Then used in income and income analysis, property prices, etc. Okay, now what's the example of median? Basically there's a salary 25k, 30k, 35k, 90k, 100k. Now see, the data is arranged in ascending order, then the middle value, that is 35k, which is median. Okay, so basically median is the perfect balance. It splits the data into two equal halves and making it ideal for dataset with extreme value. Okay. Now the third is mode, the most frequent value. So what is the definition? So mode is the most frequently occurring value in a dataset. So it's best for categorical data, can have one mode or two modes. So if it have one mode, then it is said as unimodal. Then if have two modes, then bimodal or mode. And used in marketing, product demand analysis, this kind of thing. Now what is the example? Like shoe size, if we written the different kind of means suicide, or the suicide is 7, 8, 9, 9, this kind of thing. So what is the mode of this suicide, which is 10, because here 10 occurs 3 times, 9 occurs 2 times, 8, 7 and 1 occurs 1 time. So what is the most frequent, which is 10? So 10 is mode here. Okay, so basically mode tells us what's most popular, just like the trending hashtag on social media, right?
That's all for today.